In this lesson, we're going to go over angle, angle, side, and hypotenuse leg, which are two other postulates to determine whether triangles are congruent. The first one is angle, angle, side. Okay, in angle, angle, side, if two angles and a non-included side are congruent to the corresponding angles, and a non-included side of another triangle, then the two triangles are congruent. And we kind of discussed a little bit of angle, angle, side in the last lesson. So this is more just a review with the angle, angle, side. The new one that we're going to talk about is hypotenuse leg. Okay, hypotenuse leg congruence theorem says that if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the two triangles are congruent. So what's really important on the hypotenuse leg theorem is that we are talking about right triangles. Okay, hypotenuse leg has to do with right triangles. And if you think about the word, right, hypotenuse leg, right triangles is when we talk about a hypotenuse. So you know that hypotenuse leg has to do with a right triangle. So if you have two right triangles, okay, then if the hypotenuse, which is the side directly across from the right angle, if the hypotenuse is congruent, and one of the legs, okay, the legs are the sides that are not the hypotenuse. They're the ones that connect to the right angle. So if the hypotenuse and one of the legs are one of the corresponding legs, okay, so it has to be, you know, this leg and this leg are congruent, then those two triangles are congruent. So here are some examples, and this includes not only what we're learning this lesson about angle, angle, side, and hypotenuse leg, but we also include all of the other theorems that we've gone over so far as comparing triangles. So in this one, what postulate or theorem can be used to prove that triangle ABD, so this triangle right here, is congruent to triangle ACE? So that one would be this one right here. Okay, so what we're wanting to do is prove that these two triangles are congruent, and then which one of these would we prove? Okay, well, first of all, we don't have a right angle symbol, right? So we automatically know that we can't use hypotenuse leg. Okay, so now let's look at what information we're given. Here, we're given that angle C is congruent to angle B, and those are corresponding angles, right? If you look here, angle B and angle C are in the same spot. Okay, so angle C and angle B are congruent, so we have angle C is congruent to angle B. Okay, now the other information we have here is that this side, right, side AE, is congruent to side AD. Okay, and if we look here, okay, side AE or EA, right, E and then A is congruent to side DA. So those are corresponding sides. Okay, so segment AE or side AE is congruent to side AD. Okay, so we have an angle and a side. Okay, and then if we look, that's really the only information that we're given as far as congruency, right? But if we notice here, they both share this angle A, right? And what do we know about, remember the reflexive property says angle A is congruent to angle A. So that's another angle. So we have angle, side, angle. So that would be the theorem that we would prove this one is congruent. Under the given conditions, which triangles are congruent by the hypotenuse leg theorem? Okay, now hypotenuse leg, remember, has to do with 90-degree angle, right? A right triangle. So we know automatically that all we're comparing are the right triangles. Okay, so here, if you look, here's our right angles. So we know that these are the triangles that I'm looking at. If we look here, we've got a small triangle and a small triangle. Okay, so maybe we're comparing those. But then we also have these big triangles right here. Okay, we've got this one right here and this one right here. Okay, so now we want to pick which one. Oh, now we want to pick which one I want to use. Okay, so we automatically know, right? We've got these. Okay, now both triangles share this leg, right? They share XC and YA are congruent, right? XC is congruent to YA. Okay, so we know that. Now, if we look here, okay, at the hypotenuse, okay, if we look at CZ, which is the hypotenuse of this little triangle, right, and then here ZA is the hypotenuse of this other little triangle, we don't know that those are congruent, right? We don't have the little hash marks that tell us they're congruent. So let's look at the big one. Here, the hypotenuse for the big triangle is CA, and here the hypotenuse for the big triangle is also CA, right? And again, with the reflexive property, we know that CA is congruent to CA. So the two triangles that we can prove are congruent are triangle XCA is congruent to triangle YAC. Okay? XCA, yeah, YAC. Okay, under the given condition, which triangles are congruent by the angle-side congruence theorem? Okay, so on this one, we're looking for an angle, and a side that are congruent. Okay, so let's look at these two triangles right here first. Okay, we have angle A is congruent to angle D. Okay, here angle H is congruent to angle H, right? Because those are vertical angles, so we know that those are congruent. We don't know anything about the side here, right? BH and let's see, it would be BH and HC, right? We don't know that those are congruent, right? If we look here, we know we're looking for a side. Oh, we know we're looking for a side that's congruent, right? But if we look here at all the information that's given right here, we don't see any of the little hash marks on any of the sides. What that automatically tells us is that we're looking for two triangles that are sharing a side, because that's the only way that we can prove that those sides are equal. Okay, so if we look at these two little triangles right here, they don't share a side. Okay, if we look at these two big triangles right here, okay, what do we notice? They share this side right here, right? They share BC. Okay, so we know that this is the triangle that we're looking at. Okay, so if we look here, right, triangle, angle A is congruent to angle D. Okay, down here, see this little right angle right there? And the little right angle says that angle ABC is congruent to angle DCB. Okay, and then what we've already said, right? BC is congruent to BC. Okay, so the triangles that we can prove are congruent are triangle ABC, okay, is congruent to triangle DCB. Okay. On this one, we are going to determine what one other side or angle congruence pair is needed to prove the triangles are congruent, and then state all possible congruence postulates that apply. Some problems can have more than one possible solution. Okay, so what we're looking for right here is what one extra thing that we need. Okay, because if we're looking here, we know this is a right triangle. Okay, now according to this, since this is a right triangle, okay, we actually have all the information that we need right here, okay, because since it's a right triangle, right, we have the hypotenuse, right, the hypotenuse, and then a leg that are congruent. So we can say hypotenuse leg. Okay, now if we had some other information, right, we could also prove some different things. Now, if we didn't have that this was a right angle, right, if this was a different angle but they were congruent, right, then we can't prove it because this is angle side side, which is one of our theorems that we can't prove. Okay, so we can only prove this if it's a right triangle because we can say the hypotenuse and the leg are congruent. Okay, um, something else that if we had was, if we had that these sides were congruent, right, we could say side, side, side would be congruent. Okay, if we had these two angles as congruent, then we could say angle, side, angle, right? Angle, side, angle. Okay. Again, if we had this side, we could say angle, angle, side, right? Angle, angle, side. So there's actually just a little bit of information that we need, and we could use a whole lot of different postulates for this one. Okay, we want to state whether the two triangles with the given dimensions are congruent. If they are, support your answer with a postulate or theorem. If they are not, give a counterexample. Okay, so what we're given is triangle ABC, and then we're given triangle RST. Okay, we're given that the measure of angle A is equal to the measure of angle R, right? They're 56 degrees. And then we're also given that the measure of angle B equals the measure of angle S, which is 46 degrees. And then we're given that angle C equals angle T, which is 78 degrees. Okay, so what we're given here is three angles, right? So that's the information here, angle, angle, angle. But remember, angle, angle, angle is not a sufficient postulate. So we cannot prove that these two triangles are congruent just based upon that information. So we don't have enough information. Okay, the last thing that we're going to do here is a proof. Okay, so remember the proof is we're just looking at the statement, and then the reason is we're just asking, why is this statement true? Okay, so here what we're given is that AB is perpendicular to AD, and then we're given that DE is also perpendicular to AB. And then we're also given that point C is the midpoint of B and E. Okay, and from that, what we're trying to prove is that triangle ABC is congruent to triangle DEC. Okay, so the first statement here, AB is perpendicular to AD and DE is perpendicular to AD is our given statement. Okay, that one's given to us. So from this information that's given, we know that triangle A or angle A and angle D are right angles. Okay, so what we're asking is, how do we know that? How do we know that these two angles are right angles based upon this information? Well, it's because of the definition of perpendicular lines, right? Because what do we know about perpendicular lines? They are congruent. So the definition of perpendicular lines is the reason that we know that these two are right angles, okay? And now because we know that they're right angles, we also know that angle A is congruent to angle D, okay? And how do we know that? Because right angles are congruent, always. That's how we know that. Here we're given that point C is the midpoint of BE, right? That's a given. So again, we just write given. From that information, okay, we know that BC is congruent to CE, okay? How do we know that? Well, because a midpoint tells us that C is right in the middle, right? And if it's right in the middle, then we know that BC has to equal CE. So we know that they're congruent because of the definition of a midpoint. Okay, so from there, right, now we're going to say that angle ACB, so this angle right here, is congruent to DCE, this angle right here, okay? How do we know that these two angles are congruent? Because they're vertical angles, okay? And then from there, right, we've proven that BC is congruent to CE, right? We proved that angle A is congruent to angle D. We proved that this angle ACB is congruent to angle DCE. So we now know that ABC is congruent to DCE according to angle, angle, side. Right? Angle, angle, side is the reason that we know that these two are congruent. Okay? And that's how you prove that triangle ABC is congruent to triangle DEC. And that is the end of AS and hypotenuse leg.